Good evening, everyone. Welcome, HexGen. Welcome, Nikolai. Sorry I'm quite so late starting. Gonna give everyone a little bit longer to roll on in, and then we can start. And yes, I will start with an explanation of what I'm doing inside the build system, because that's probably going to raise some questions and turn some heads. Well, we're at 5 people and 3 minutes in, so I'm going to get started. First off, the build system thing. So, as you might remember last stream, I started to pull out the USB stack from SPIFlashProgrammer into its own thing we called dragonUSB. I've actually done some more work on this off stream because I was puzzled as to why it wouldn't work, etc. As we just pulled code out and compiled a library and linked that library in without changes, it should just have worked. Which it didn't. Turns out, annoyingly, GNU tools, bin tools specifically, the archiver in there, AR, does not understand how to locate the LTO plugin, which is required for it to be able to deal with the LTO objects. So, shenanigans ensued, and I've now fixed up the build system. We now have proper LTO support in AR. So, I have some loose ends to tie up from the end of last stream before we can write a DFU driver. The loose ends are to do with the sizes here that are littered throughout types HXX, and I also need to deal with the bid and PID bit. That information kind of needs to disappear into its own header, which is why I've preemptively created a constants header, and we're going to add a series of options to the build system to allow you to specify, here's how many endpoints I need, here's how many interfaces I'm using, here's the number of interface descriptors I have, etc. So we're going to set up a set of things you can pass dragonUSB to build the stack appropriately. And then we can get into DFU. So, I think the first thing to start off with in the descriptors here, or rather the types, will be the number of configuration descriptors available or used. I don't recall if it's count or if it's integer, but luckily Meson is very well documented, so let's go and look it up. It's not built-in options, but it is build options. There it is. Integer. Okay, so integer has a minimum and a maximum. Apparently I can't words. That's a terrible joke. XGen at it again. How many config descriptors should we max this out at? Probably about 8. Can't have that many. Well, I think theoretically you can, but it's dumb. I think it looks like its value is the default value. What I should do is I should open the standard and find out. That one. Not USB PD. Try that one. There we go. The other thing I've done since the last stream was I also fixed a whole pile of warnings. As you can see, there's been many rebuilds that I've done. So we've now got, well, that many warnings. That's it. Which is much, much better than it used to be. Well, so assuming I get this bootloader done quickly, then the next MX keyboard stream will not be too far away, because I actually need the DFU bootloader to fix the problem we hit with MX keyboard. That's why I switched to doing this. Yeah, I'm crafty, aren't I? No worries. Is there a defined maximum number of configuration descriptors? Looks like the maximum is actually 255 configurations, which is, well then. I don't think you'd ever actually get that many in memory, though, with the stack, so I think I'm going to leave the max at 8. I think, let's try iFace descriptors. That way we don't have stupidly long option names. There must be at least one interface, otherwise you've not given it a valid descriptor set. Yeah, each configuration has one or more interfaces, and each interface has 0 or more endpoints. So, iFace descriptors, type integer, minimum 1. Let's set the maximum number of interfaces at 32. I'm not sure why you'd ever need that many, but we'll make it that many. We then have endpoint descriptors. Which we start with 1 and... Ooh, how many can you have of those? So technically, technically the maximum of that is 16 by the number of configuration descriptors. Actually it's probably even more than that, because it's the number of interface descriptors and... that gets a big number fast. Whoops. I just triggered an MX keyboard bug. Let's do 64, because that's 4 different complete sets of endpoints. We can always change these, that's the nice thing about this. So having set number of configuration descriptors, the number of interface descriptors, the number of endpoint descriptors, there's interfaces, which is the total number of interfaces provided. And there must be 1. Technically the minimum number of endpoint descriptors is 0. Maximum number of interfaces. Let's set this to the same as the number of interface descriptors. The only time that'll be wrong is if you want to do alt modes. And the other one that we need is endpoints. Which the minimum number is again 0, and let's set this the same as the... No, we can't set it the same as the number of endpoint descriptors. Endpoints is separate from that. I think... this needs to be the maximum number of eight. I mean, as an example, this USB core has... Xenobyte Offsec, welcome, thanks for the follow and welcome to the stream. Well, yes, I am doing that a bit right now with the way that this all works. So there's the endpoint 0 endpoint, which is whatever, and then there are 7 in and out endpoints each. And I think I want the endpoint number to be that, rather. I don't want to include the number of control endpoints because that's stack internal. You can't turn off that control endpoint. So I think I want the number of endpoints here be 7, with a value by default of 0. And that gets us our basic set of configuration points. Oh, the other one we will need, because currently it is in types here, which is probably not the right place for this, is going to be the endpoint buffer size, which is a max of 64. Which I'm just going to directly call the option the same thing as the variable in the code. Minimum is 8, maximum is 64, with a default value of 64. An additional item I've noticed looking here is we actually do need a number of string descriptors. Which has a minimum of 0 and a maximum of a byte. And I'm not going to provide a default value, there's no point. Oh. Welcome, Marcos Fraj, I think is how I pronounce that. Thanks for the follow and welcome to the stream. I do very much enjoy Linux, yes. See the description we'll need to fill out for every single one of these. Oops. So, and have the... Hey Aston, welcome, welcome. So I got the number of interfaces, the number of endpoints, how big a buffer to use for endpoint data, how many configuration descriptors you have, I actually would really be interested in seeing that happen. If nothing else, because I think that the current proprietary ones are a pile of steaming junk. And open source TPMs mean the ability to actually review the cryptographic implementations. Audit them, make sure that they're doing the right thing, that they're not doing anything naughty. Oh yeah, it's just a chip on a board, but what that chip does is it runs firmware, and that firmware can have bugs. Because they're not just a security chip, they are actually a microcontroller. It's terrifying. The only company that's actually managed to do better than that is actually AMD. The security coprocessor found in all Ryzen chips, and therefore all EPYC chips, does implement TPM. It's a virtual TPM, but you're just trusting them to do it right. So, and good luck if you ever want to update because, oh, I don't know, it supports a now broken algorithm. No, AMD motherboards do not. They just need the virtual TPM enabling. Good. AMD did good. Intel people are still screwed though. I would not enable that TPM anyway though, because honestly, with the way that TPM works, it actually degrades security. Yes, they are. Yeah. Actually, I'm just gonna rename strings, string descriptors here to just strings. How many strings you have, that need sending over USB. Oh, I wish. Oh, no. It's bad. Right, having defined all of that lot, if I quickly run the build system, integer option must contain value argument. Ooh, interesting. Well, I set the value then to 0, just so it's got one. And if we look at the configuration now, project options doesn't actually have, oh, that's, sorry, wrong one. Project options here now has a set of definitions for all of the different descriptor counts, etc., so we can tune them. But the most important thing this has done, yes, agreed. But now what we can do, having defined all of this slot, is we can replace all these constants that are currently in types HXX with a proper set that are derived from the build system, and we can pass all of these in as options to here. So if we do is it CPP args? I am having an entertainment setting up to write the bootloader, yes. It's a static library in this case. Not that it matters, they're all types of library, which are derived from executable. Ooh, indeed. That's fair. Though your soldering does look very good, for what it's worth. I was very impressed. Right, yeah, I thought so. So it's CPP args, and we're going to have to manually set everything up, but that's fine. So if we have build defs, let's say, and a series of substitutions that we're going to perform. Which we then pass in with CPP args as build defs. because everything is C++ here, which makes life very easy. We start out with this will be endpoint count. Get option. Actually, I'm gonna do this as USB endpoints. That'll be better. Then we have interfaces. Then have the endpoint buffer size. Oh, I nearly had enough of these. There we go. Now we do. Config descriptors, interface descriptors, endpoint descriptors, and strings. Oops. Indeed. Oh, Eston. Oh, Eston. It would be complicated to do for a few reasons, but we will eventually look at putting an FPGA in an MX keyboard design. The benefits in this case, though, are quite low. You're fine. You just don't trust yourself enough. Yes, I did just call you out. Did I miss the number of I missed the configurations count, didn't I? Oh no, that's config descriptors, never mind. No, Hexchen, you lie to yourself about my friend too much of the time. That's why we call you out. Okay, having done that, I need to do a quick build so that my IDE might have the capability to see all of that. Yes, you do. You're my friend, and you're lying. Therefore, you lie to my friends. Not that different. Complaining there about that. Also, I just noticed a lowercase t. Whoops. Oh, would help if I did get option on all of these. And I closed the get option brackets. Ha! Better. Oh, because this is iFace descriptors, that's right. Yay! It builds again. So this is just me reconfiguring my IDE so it knows about these new values. So we've got interfaces is 1. Got endpoints, which is currently set as 0. Buffer size is 64. Interface descriptors is 1. Endpoint descriptors is 0, I think. Yep. And we've got one config descriptor and no strings. There we go. That just means that my IDE will actually cope with this okay. Client ID also needs telling about those. Oops. Bingo. Okay. So, having done all of that, let us do some quick version control shenanigans, and then I can actually get on with the proper part of the stream. Okay. So currently, here for example, for the endpoint counts, etc., we're in USB types, but we actually want to be using USB constants. And if I yoink stuff from types here completely, kind of. They need to be approximately the same length as all of the other SPI bus traces to the first one at the very least, because that's the signal on which all of the data is being clocked in on, so it is a bit critical. But also you're running at 32 megahertz, so... oh, 16, sorry. So, there is some room for some skew. It just helps to keep the skew down. Does that make sense? Anyway, moving along. In here, I think we're using... yeah, no, we're not using those constants anywhere else. In here. Wunderbar. So this is mostly it having a time in the descriptors header, which is understandable. And we can then change this. And then we also need to do the same thing to both device CXX and core CXX. Not too bad. You've got 6 layers, HexGen. You can use one of the other inners. Preferably don't do it with the one right on top of those traces, which is the 4th inner. But you can do it. Be fine. Okay, we're down to 1 file left to fix. And again... we'll do some using magic, and then we can get rid of the prefixing here. And yeah. Excellent. So switch to using the new configuration constants system. Now if we pull that, and we fiddle with this project's settings. Whoops, that was not the thing I wanted to click. Let's see. So we are using subprojects, or rather, we're using dependencies to pull in subprojects. Default options is one thing. Is there override stuff? Nope. So, okay, it is done using the default options bit. That's fine. There we go. Dragon USB. Here we go. Yes, but if you've noticed on the other drivers, where I've had to, I used, for example, route 6 to be able to route stuff for route 4, where I'd run out of space on route 4 in terms of it actually working with the rest of the... I think you'd need to show me a screenshot, but I bet you can do it without having to butcher those traces, because if I was able to do it with more drivers on the board, you should be able to do it. But we'll have a look at that later, together. I don't mind doing that. How to most easily copy the set of settings I need. Guess actually just grab that and we'll then reformat it. So, we have two interfaces so far on SPIFlashProgrammer. We've got the actual SPIFlash programming interface and DFU. We are using two sets of endpoints. We are using 64-byte endpoint buffer sizing we have one config descriptor, 2 interface descriptors, 4 endpoint descriptors, and 4 string descriptors, if I've recalled correctly. Let us check it out and see. Oh right, I removed them from there. Let's just see what happens then with this lot. Oh right, I need to update the project files on, well, the IDE configurations on this one too. We don't need... We don't actually need any of those, but we do need to define those other bits. Like that. So we've got one configuration descriptor, one interface descriptor, but that's soon to become 2. We have 2 endpoint descriptors, soon to become 4. Four string descriptors, I seem to recall. Yes, because of the +1 of that. And the endpoint counters as well, 2. Let's give that to Clang Tidy so it stops complaining. And see what happens when we run a build. Yeah, because we're doing default option stuff, it just ignored the default options we gave it. We can fix that really easily though. And this is a problem only because I'm reusing my build directory. There's the string count, endpoint descriptors. I can't spell. iFace descriptors. Config is already set correctly. Endpoint buffer size is already set correctly. We need to set endpoints. And interfaces. Ah, right, yes. I need to bake those definitions into SPIFlashProgrammer's build system as well, but that's not too terrible. Those, I can do it through the dependency object. So the dependency here can define build options. Which is thankful. I think it ends up being CPP args here as well. And it will be build defs, because that's what we've called it in the inner. Good. Passed invalid keyword argument, CPP args, line 74. Declare dependency. Ooh. How does that work then? Oh, compile args. Yep. Excellent. Added the... yes, they are quite a lot more expensive. Worth it though. Added the... build arguments required to use the library to the dependency object. Mm-hmm. So if I again pull that, and we rebuild, much better. Now it's no longer complaining that it can't see those definitions. Let's see. I deleted the vid and PID. Let me quickly go grab that back out the commit history here. And let us put that in a constants file here. What namespace are we putting everything else in? Oh, I haven't been, that's right. Yeah, okay. Yeah, no need to put a namespace on this for now. There will be in the future though. And let us include cstd_int so that this can see these type defs, which are actually usings, and then let's put the constants in play. And let us also include our constants header. Excellent. So we're now operating with the stack entirely configured using those definitions, which is really good news for what I want to do next. See, I had it in mind when I moved everything out of the firmware that the stack would become a lot more plug and play, which is what we're aiming towards here. So if we add the new bits, that didn't end up becoming a thing. Which is a good thing. Yeah. So this change integrated the new USB stack configuration system with our build system. Okay. So, DFU driver, there's a drivers folder I've started, which we're gonna create DFU CXX. And in the includes side of things, we'll also have under USB drivers, and if we need any header stuff for DFU, which we probably will, like for example a registration call, then we now have a header for that, which we'll just stick that over there. Put this on the end. Okie dokie. So, DFU. There are a few parts to it. There, first and foremost, are these zones, which, if you saw last stream before I started pulling apart stacks, this was the thing I started looking at from the Nitro FPGA repos that Sylvia created and maintains. These are all written in C, and they do some C crimes, and obviously the lack of documentation comments can be a little bit interesting at times. But from what I understand, the zones get fed into the initialization call for DFU, and this is where the driver registers itself up onto the stack that Sylvia wrote, which unfortunately doesn't target this platform, and yeah, there are a few things it plugs into. There's some descriptor bits, there's some state bits, there's some control bits, and apparently it also wants to look for like bus resets and start a frame. That's going to become a bit interesting in a bit. I can hexgen, yes. This is the main state machine for DFU. So for example, upload request, download request, attach, reattach stuff, tick does some fun things. And then there's this GDFU, which is a global state structure. Now, gosh, I think we're gonna start by defining the zones system. These will be some optional options. And gosh, how do I want this to work? I have a slight problem here, which is basically I'm not sure how to pass these zones in to configure DFU. Although I do have substrates span, so we could pass them as a span, and that preserves a type and size. This fun thing. Yeah, okay. So substrate span takes a single template argument, if I recall correctly. Yeah, which is the type to make the span of. Which in this case should probably be input-a-t. Which I think is in C_def. No, C_student. Now, because of how all of this fits together, we're going to need to define an option for use DFU or enable DFU or something like that. So let's go with enable DFU, yeah. Or, no, ooh, I can do it better. Drivers type is going to be combo. Oh no, was it combo or... The one which allows you to give it multiple... It's an array. I want an array here. What this will allow us to do is basically say, hey, I want the DFU driver, pass in drivers equals DFU, and that turns on the DFU driver, at which point we just get to use it, as it will be compiled into the Dragon USB shared, static library. So, Meson.build in there, because we're going to have to do some fun stuff to make the drivers work. And we want to get all the drivers, and if DFU in enable drivers I think is valid, check the Meson help. Syntax. What we're doing is we're checking for membership of an array. Oh, dot contains. And I don't think actually I need a colon on the end. Nope, I do not need a colon on the end. So if enable drivers, the array we've just got, contains DFU, then drivers plus equals file DFU CXX. And if we make drivers an empty array, that will add, if the option is provided, that will add the driver source file to the build. Simple enough. Which, for the purposes of testing, let us actually do. Let's do a rebuild real quick, and then Meson configure drivers DFU. Oops. I know what I've done wrong there. Files is the call. There we go. Oh, whoops. Take care, Hextron. Thanks for dropping by. How to turn off use of type ID with no RTTI. Well, let's actually see if I do no RTTI. We do a preprocess run only, and we ask it for what it's gonna set the environment up as. That should be for C++. There's a way to force GCC into the right mode. Oh, that's a regex. That's right. There we go. -X C++. There we go. Hey, bingo. So we have C++ attributes, non-template, parameter auto. I wonder. It doesn't define anything specifically for RTTI. Does it define something for... I wonder. Does it define something for... type ID. Okay, interestingly, that does define JXX type info equality inline. That does look to be the one, actually. So if we take out the no RTTI stuff, I don't know, it doesn't actually change anything. How to determine if type info is available? Trying to think. GCC no FRTTI. F no RTTI rather. Macro definition. Ah, GXX RTTI. Let's see what that's doing. There's RTTI without the option to turn it off. And with the option to turn it off, it disappears. Perfect. I can check if GXX RTTI is available. Which is going to be somewhere deep inside substrate. This. I think that's the macro I need to correctly turn this thing on and off. Yep. So what this is doing is if we're not GNU-C, i.e. we're not GCC or Clang, and this thing is, all this thing is defined, then enable this, otherwise don't. That is a substrate bug, so let me quickly find substrate and fix that properly. So with that done, let me actually also push that to GitHub. Is it not Git? No. Sure, whatever. Close enough. I think that one's automatically mirrored. That's why that didn't allow me to do that. So let's. Good evening. Welcome, Amy. So let's go into depths, substrate. Not quite where I want it to be. Actually, it's restore, isn't it? Yeah. I'll have to update substrate in a couple of places to make this all happy. Okay, good. So, what that's allowing us to now do is we can pass in the zones information into the driver initialization rather than having to hard code it somewhere inside the driver. We will also need to register suitable endpoint handlers. Now, DFU, according to the spec, which is technically incorrect, has some requests it can have made. This looks like these are on the configuration endpoint, EP0. So we'll also have to hook... ooh, this is going to be annoying. I haven't actually currently got a way to hook configuration endpoint stuff into a driver. This is actually device, sorry. So handle setup packet. Here, we need some way, if unhandled, to go through all of the possible class-specific request handlers dispatching stuff. Did I have a header for device? I do. Which for some reason was way down the end. Okay. I'm gonna need another control parameter, aren't I? I need to be able to control the number of registrations that can be made, which for the handlers was easy because there are endpoint count -1 by configs count endpoint drivers or registrations that can be made, which makes my life nice. But for the number of request handlers, that scales in the number of drivers that you have that you want to do stuff with. And the number of configurations. Which is very annoying, actually. Let's, same as alternative modes, let's do this in the number of interfaces and the number of configs. That'll be close enough. So this is config handlers. And we will need a type to handle or hold a handler. So let's do using control handler T equals. I call these config in here. No, it's control handlers. there isn't a specific endpoint that you'd register it on. Instead, it's the interface? Yes, it's the interface that this is registered on in a configuration. And the handler is a const endpoint, const control handler T handler. Should be right. Oh wait, no, that's wrong because yeah, that const is in the wrong space, wrong place. There we go. Where do I want to put this in here? So oh, I also will need to pass in which interface we're being called on. And what the setup packet data is. Handle set configuration. That's a endpoint. Those are kind of a bit of a pair. You have various handlers. Read control, write control. Complete setup packet. So we probably want to put this in just below handle standard request. Config control handler and this is control handlers interface, no sorry, configuration interface is handler. Now that's actually not the right line of code, but it'll do to get started, because we actually need to check that it's in bounds and then subtract 1 from each of those two numbers. So we want to be able to pass in, for example, configuration 1, and then it'll actually assign to the 0th index in that array. Let's just check that the indexing is correct. Configs, then interfaces. Configs, then interfaces. Yep, okay. And internally, that is not a uint8t, that is a control handler t. Minus the big typo. So if not interface, or interface is more than the number of interfaces available, or the configuration's wrong, or the configuration is more than the number of configurations available, return. Do nothing. Otherwise, sign as so. And unregistering works in not a dissimilar manner. And we want to return this to a null pointer when we unhandle a thing. So, here, if response is a response T unhandled, i.e. it was not dealt with by the handle standard request function, then we want to do stuff. Now, I actually also need to go and grab the keyboard's code real quick, because I've actually already partly sorted out how to make this work here in the keyboard's code. So if we look at how this is doing handle standard request, this is where stood tie comes in, and we need to actually define all of this stuff up front. So, alright, we don't need the memory T bit because we aren't doing that. If response is unhandled and active configuration, i.e. we are not in the deconfigured state, then for, let's see, before const auto handler in hey, nice. Ooh. Oh right, I will need this to be a substrate enhanced loop indexed iterator on config handlers active config -1. Config, oh sorry, not config, again I've done that again. Control handlers. So what this will do is it will go through all of the handlers that are currently available. If handler, then handler I+1, which is the interface number, and packet, and we stood tie the result. Meaning this also needs to return a USB types answer T. Ooh, excellent. Nice job, Esden. Yeah, VMware is weird. Fair enough. I'm intrigued why you didn't go to VirtualBox, but you've got your reasons, so... yeah. Oh, interesting. Okay. I thought size was indeed a size T, Unit 16T. Answer T. Oh, okay. I defined it as a Unit 16T. I wonder why I did that. Oh, no, I know exactly why I've done that. Ha. Fine, that's easily fixed. This is because Uint 32T, rather a stud size T is a Uint 32T on this platform, which would cause us some problems due to limitations. Let's make that a size T. It will never be more than an 8-bit number, but that will make my life easier when using it. Then I keep managing to open a new console rather than just doing a rebuild. That looks like we got rid of the warning. Cool. So, with all of that done, we can now define how DFU handles control requests and allow the registration for a given interface. So we need to have the interface number. Oh, yes, you've got to do some fun stuff with that, haven't you? So, our control handler needs to take answer T as a result. What do we want to call this? This is handle DFU request. On the interface. With the given setup packet. And against the device we call register handler interface handle DFU request. Oh, right, forgot about the configuration aspect. What am I doing in FlashProto? Alright, I take the configuration as another configuration parameter. Oui, mais je parle un petit peu de français aussi. So, I actually do understand the lyrics. No return statements in function returning non-void. Right, yes. So yeah, we now can handle the DFU requests. Perfect. We by default want to return unhandled. But if packet index not equal interface return unhandled, let's see. I'm going to put the other DFU driver code that I've got here, which is from Sylvain, over on the other screen, as I'm going to need to refer back to this a lot, it would seem. Let's see. Handle control request. If the control requests interface is not that, then unhandled. Otherwise, if I'm gonna need these request types as proper numbers. Oops. Because this is a setup packet request T, which that enumeration does not work in this case. Ugh. Is it this types? No. Oh, it's in device, that's right. So we are messing inside of this. Got a type which is yes. Type will be type vendor, and the recipient should be an interface. Aha, yes, okay. So if packet, well, const auto ref request type packet request type, because otherwise this is going to get super repetitive. If request type recipient is recipient T interface, sorry, not equals because I'm in a negative logic if statement here, or the request type is not a setup packet request T type vendor, or the interface doesn't match. So what we're doing is we're going through checking several things that need to all match in order for this to be an actual DFU packet that we've got. which should in theory all be encoded in here. If I compare and contrast, trying to find the right part of the standard. This takes a moment. Here we go. So, every single one of these, this topmost bit here is which direction it is, which we don't care about right now. The next bit is a constant. The constant means vendor. Sorry. Is that vendor? Five. No, those are class. Those are class types. And then recipient, 4 down to 0. So these bits are all interface. So let's fix that little blunder. This is type class. This means this is something for us to handle, and it's on the right interface for us to handle it. The request values are going to be request T's, which is very much a problem, because that's this enumeration here, which does not handle what we're dealing with, which are class-specific ones. Which is this lot. So let's define the enum class required. So those should be all the request types, according to this table. Which, yeah, very much map onto the same set of numbers as that, which would have been bad. Yeah, const auto request request is the static cast to a request T of request, sorry, not request, packet request. There we go. And then we can switch on that, same as we do in handle standard request, all the way up here. Now, this is where I need transfers to be able to support callbacks. Because, for example, the detach callback, which we've just defined here, should cause a reboot from DFU mode back into the application, whatever it is. Upload, download, gosh. Get status. So there's a state that we need to hold on to. Which is there actually a definition for all of the different states? Yes. There's a point. I actually need two headers for DFU. We're going to have DFU HXX and DFU types HXX, so I can actually move all the type stuff out into its own header. And we'll do header guard, if and def, USB drivers, DFU types HXX, define it, and if, that way we don't get multiple definitions, and we will need include cstd_int, otherwise this will get mad at me. And then we can include that here. That's complaining because that was ambiguous. I think. Yeah. There we go. I don't really have a very good definition for all the states from this other driver. And there's also status. VS Code being funky. Detach. Application idle. DFU idle. Download sync. Download busy. Download idle. Manifest sync. Manifest wait reset. Upload idle. Error. So clear status is going to be the easiest one to implement because it's for error cases. So if request T, it probably doesn't know which one that is, or rather, sorry, not if, case request T, yeah, is ambiguous. Clear status. So if how does that work? If state is DFU state error, state equals DFU state DFU idle, and we'll also need to do the OK status thingy, and then it doesn't actually say what to return in that instance. It's not unhandled anymore. Is that like a zero length packet? I guess that's probably zero length packet. Data none. So yes, that's return a zero length packet. This specification drives me bonkers. It's not a well-written specification. Ah, these are the statuses. Okay. Enum class DFU status is unit 8t in size There's an OK status. There's a target error. There's a file error. There's write error. That's pretty obvious. There's erasure failure. Programming error. Verification error. A not done error. That's for incomplete. Firmware corruption error. That's actually quite useful. Vendor specific error. There's then a USB reset. USB PR. Unknown. That's something you probably never want to see. And stall caused errors. We'll need one of those in our global state. So that enables us to deal with clearing status. Make sure that we actually configure up in the initial correct state. I should also make these static. And this. Okay. I'm guessing DFU abort is also a returns nothing thing. Yep. Data none. After the host and device agree to perform DFU operations, the host re-enumerates the device. So during that moment, that's when we get to reboot back into the bootloader. DFU mode, device descriptor, duration descriptor. Okay, so this is the status data. Let's define that as a structure. First part of this is a DFU status. We then have a very weird timeout thing. Let's do that as a std array for now. Then there's DFU state and a uint 8t containing a string number. And I'm actually very inclined to shove state and status into that and just use them. That way we save some bytes. This is actually our configuration. I will define an initialization function.
There is certain communication here, but exactly what this body language is saying is still the subject of intense discussion.
We'll expose this init through the handlers interface in a bit. So we've got get state and get status. Get state returns the state member. And get status returns that global state that we've just defined. And we can actually do a static assertion to make sure that that's the proper size. Because it should be 6 bytes. Which it looks like it is. Good. That's 3 unhandled things. That's not bad. And it compiles. So let us add this to the repo. There's the handle, the control handler's registration code. That's all of the DFU code. Done implementing a DFU driver. Which if we... let's actually try and use it in anger. So we have change to make to the build system. And then we can include the driver header and USB DFU, that happens to be where it is, register handlers. There are no zones yet. We want to do this for interface to configuration 1, I think is right. We'll also better write some descriptors for this. So descriptors is something I'm a little bit conflicted about, because ideally I want, for example, the device descriptor send code to be defined in Dragon USB, and then we just define the descriptor and it works. That would be ideal, but that's actually very difficult to get to work right in this current design. I need to do some off-stream thinking about how I want that to work. So the one thing that's bothering me at the moment is I'm not sure. Oh, actually, let's plug Blackmagic Probe in. I was going to say I'm not sure which interface I need this to, or how an interface for DFU needs to be defined, because that's not clear in the documentation. But if I plug Blackmagic Probe in, which it is, and it's happy, and we look at the interface descriptors that it has, so this is this device. Oops, try VD, not DV. We can see, other than this being a dirty build of the firmware because I was doing things, we have a CDC ACM device, which has got two interfaces within it. So there's the first interface here, and the second interface here. We then have another one Likewise for the UART. One interface for DFU. And that interface only needs to define a DFU descriptor. That's it. There are no endpoints required, at least in this part. Okay. I thought I was going to need extra endpoints, so we actually need to edit the build system again. Because endpoints, we only need one lot of endpoints. We don't need two. There are two interfaces, two interface descriptors, two endpoint descriptors, and there'll be 5 strings by the time we're done. So to this we add size of USB interface descriptor, and size of USB DFU descriptor T. Is that? Yeah. So for that to work, that scrolling thing's gonna get so maddeningly annoying. Descriptors, we need to define a set of types for namespace DFU. Let's see, Oh, DFU only uses the control endpoint. Oh, fun. So there's a uint length. There's the descriptor type. There's an interface number. The alternate mode must be 0. What did I call it for the other thing that needs alternate mode stuff? Alternate setting, okay. Number of endpoints must be 0. Num endpoints, looks like it might well be. Yep, num endpoints. The interface class. Did I define a enumeration for those? I did, USB class T. The subclass will be DFU. Did I define any subclass type thing? Nope, not yet. And then the protocol. I'll actually call this DFU subclass DFU protocol. Subclass and protocol will be fine. And then this is the string descriptor bit. We'll make it that. There we go. That scrolling thing really is driving me mad. Defined descriptor types for DFU. Actually, I'm going to amend that. Interfaces. How's everyone doing, by the way? Hopefully this isn't too boring. I do appreciate that this is a lot of watching me write code while I'm guessing at what I'm doing. Oh, that was an interface descriptor T I've just effectively defined. Whoops. So it'll be interface index 0, alternate 0, no endpoints. There's application. And which string literal do I have free next? My next free string literal is 0, 1, 2, 3, 4, 5. I'm just going to check something on my device's interface descriptors because I'm not happy about one thing about this. So this is generic SPIFlashProgrammer Rev 2. Configuration. Yeah, the configuration index string is wrong. Ah, that works. No string to describe this configuration for now. This is Flash Access Interface String Index. And I think DFU interface is probably suitable. Or let's actually change that. That's gonna be SPIFP firmware upgrade interface. So let's add a new string. And this has, oh, how many characters does this have in it? This has 45. I think that's right. Yeah. Five plus 1 . Also realizing that these are all unsigned additions, so we should make them unsigned additions. Take care, Nikolai. Thanks for watching. Yeah, sorry this has been quite such a trudge of a stream. So strings is now 5. Ah, right, I need to transcribe the changes I made to the build system to the build system. And then also to the IDE configuration, so it stops throwing errors that don't actually exist. So this is Dragon USB endpoints is 1. Endpoint descriptors 2, and strings 5. Plus drivers DFU. I'm going to turn bug prone string constructor here off because that is actually correct. Yeah, it pains me that none of this stuff is being done inside a Dragon USB, and it's all user code. I do need to fix that at some point soon. Let's see. So the error now is that the subclasses and protocols are not defined properly because I took this to mean a DFU specific thing, but it's actually the interface descriptor type all over again. So everything I did there was wrong. So as an application descriptor type, this is DFU is 1. Whoops, application T, not whatever I just tried to write. And this is DFU run time is 1. Actually no, let's just make that protocol runtime. If that's wrong, then we update it later. That gets rid of those. So this is functional descriptor is length, descriptor type, which is value 21 hex. I'm writing those in hex up above. I am. Oh, good. And then there's a bit mask for attributes. Which I might make a fancy type for. Stood array of uint8 t 3 detach timeout. Unit 16T. Transfer size. Unit 16T. DFU version, I think is how I would put that. Yes. Which in this case is going to be 1.1, I think. Oops, try 9. Yeah, would you like to actually show me how big it actually is then? Let's put GNU packed on it, and that should make that problem go away. This is caused because of alignment. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, the attached timeout is a Unit 16T. There we go. And if I don't have packed, I'm betting it's still wrong. Yep. So that's a packed structure, that has to be whatever. Fixed a series of errors in the DFU descriptor types definitions. And then if we do a git pull, this should now be much happier. And this gets to be size of DFU functional descriptor T. Where do I want to put that in this little lot? I guess here will do quite nicely. So that we can then correct the config sections bit here, because this is now wrong. The number of configuration sections is 6. Including an interface descriptor. should do the trick. So this this makes it so that this will actually get put out in the descriptor stream. Let's see. So we have size of DFU functional descriptor, DFU descriptor T functional, then let's do 0 for attributes right now because attributes needs to be made much nicer. Let's try no timeout, just for now. It is wrong, but the maximum transfer size is going to be EP buffer size, and DFU version is there. X0110. I think that mostly covers me. I need to find out if that's actually the correct value for this BCD field. And I'm not sure how I'm going to do that because it just says BCD, which is not helpful. But yeah, so I'm going to make it so we've got some types here for the different things that you can set in the attributes, and a type that allows you to order them all together, or rather not a type, a function that allows you to order them all together to create this bit mask. I want to make that work though. So we've got enum class will detach T is uint8 T containing yes as value. 1 would be bit 0, 2 would be bit 1, 3 would be bit 2, sorry, 4 would be bit 2, bit 3 is 8. And we'll have copies of that so that we've got manifestation tolerant, no and yes, with that being that, can upload, no and yes again, and can download. And then a master structure, which we'll use to actually do stuff with. So this is struct attribute T final. And this... how best to do this? I think it's going to make this take a have a constructor that takes one of each of that enum set and builds value from that, which we can do in const expra. So const expra attributes t const will detach t const manifestation tolerant t const can upload t const can download and download and we just all these all together with casts. We can then have getters that allow you to pull out the individual bits. That shouldn't be narrowing. Oh. I hate integer promotion right now. Because of integer promotion, that massive set of ors is actually a uint, which is a 32-bit number. Because of course it is. Grumble, grumble, grumble. I'm actually going to change this then, because that looks horrible. That's better. So we have const expra will detach t will detach, which is the cast to a will detach t of value masked with will detach t's yes. Which needs to be a uint 8 for that to work. I actually have to agree with that. That should be marked no discard. And we'll then do the same thing for each of these. So if ever you need to get out whether you set if you can download, for example, then this enables that. There we go. Missing semicolon, and we have an attributes type. If we now pull that, bingo. This will detach. It is not manifestation tolerant. It cannot upload, sorry, and can download. That will mean that you'll see a reattachment happen when you call the DFU stuff, because we need to reboot into the bootloader. The manifestation tolerance thing is this device is able to communicate via USB after manifestation stage, or phase rather. No must see a bus reset. So yeah, I want to say that when we see DFU detach request, we will do a detach and reboot into bootloader. For the firmware, and if it's done in the bootloader, yeah, probably actually the same thing there too. We'll need some way to tell the bootloader that we're rebooting because of DFU though. Now, the next thing here, the upload and download parts are fairly obvious. Upload means that we can read the firmware out from the keyboard, which we don't want in this case, or the SPIFlashProgrammer, etc. There's no point. And the download part means you can update it. So if we build that, I've managed to misspell application twice in 2 different ways. One in the firmware, one in the header. There's the firmware one. Application, there we go. And that was the header one. This was USB descriptors, protocols. Enum classes. And there we go. It now builds. There's a lot of warnings, but it builds. So if we do a Ninja program, it re-enumerated. That was good. And if we ask for the vidpid stuff, we see configuration value, number of interfaces 2, good. There's our original set of interfaces, then an interface descriptor that we've just built. That returned an error, which is a bit weird. That one was right. Will detach manifestation intolerant, upload unsupported, download supported. Okay, those are all correct. That's a bit interesting though. As for the device qualifier, that's correct that it can't get it. And likewise, debug descriptor, we turned both of those off on purpose. Specifically because we're doing a USB 1.1 device, technically, even though we're giving it USB 2 descriptors, that is, USB 2.0 full speed is USB 1.1 full speed. You do not implement the device qualifier, but you do give a value in the device descriptor of 2.0 for the version. BCD DFU version there feels wrong because that's saying 1.1, whereas Blackmagic Probe here is saying 1.1a. Why? Let me just quickly look in the source code for Blackmagic Probe at the native platform descriptors. Is it native platform? No, oh no it's not, it's the general platform descriptors. That's right. skip that one because too many lyrics. Where are the descriptors in Blackmagic Pro defined? Looks like it's sources, platforms, commons, cdc, acm.c. Yeah. Here we go. Data endpoints. cdc unions. Functional descriptors. DFU. Ah, that A is literally an A in the hexadecimal. Like that. Which is what we want here. I'm not sure that this detached timeout, what to do about this detached timeout rather. We could try and define it. Or we can leave it exactly as it is, which is hilariousness to me. Let us do some version control on this repo. The SPIFlashProgrammer CSX changes I want to keep behind for right now. That will be a separate commit object. But we want the descriptor changes. Added DFU to the descriptors. Pardon me. Added DFU driver registration to the startup code. Yeah. So I'm trying to work out how the DFU callbacks stuff is supposed to work. think I need to look at adding callbacks for... Oh hey, the auto-scrolling thing's stopped. That's nice. So if we look in device here, we already have some level of callbacks in complete setup packet, handle controller out packet, handle controller in packet. Handle controller in packet's addressing stuff here is effectively a callback. So what I'm wondering is if that is how we go about making the DFU driver work. Status state. Detach is going to be the next one, I think, actually. So in our DFU driver here, case types request t detach USB core, which I need to include because I added a function here to allow us to detach. We then get to do a reboot to bootloader. Oh, hang on. DFU detached none done CB. This is supposed to return a zero length packet and then do the detaching. So what I'm thinking, device here, is it device? No, this is core, isn't it? We have the endpoint status stuff supported by USB EP status T, which if we look in types, EP status, this could have a post-transfer callback. In fact, that's probably how we're going to have to do this. Because I somehow need to be able to, on download, set up some way to request more data as part of the completion of the request. So we send out the zero length packet that confirms that we're okay for download, and we arm the control endpoint for the download, which will be a separate thing from the main control endpoint handling for reasons. Oh, this is a blasted pain actually how this works, because control stuff was only ever supposed to flow through the control endpoint, never data like this. I'm gonna add a callback here. Which by default will be a null pointer. And here we can do a USB core this will be controller in. And we can set that as the detached callback, as the detached call. Actually, as our own detached call, which will then call that. This calls USB DFU CV reboot. Ooh. I could have sworn there was a thing here as well that you needed to do. And I can actually mark this as no return, because C++ actually allows me to say this function should never return. So if we make this while true continue, that will now not return, which makes it match its marking. Words are hard. So this is a response T 0 length null pointer 0. I think this is not clear. The spec is very much not clear. Detach has a timeout. The data is none. Okay, so the state is actually changed to DFU detach. Which apparently we don't have an actual state for. I feel like that's probably suitable. Huh. Yeah, that is currently annoying, isn't it? Reconfiguration phase. An operator initiates a firmware upgrade operation by executing an application on the host. This application requires the operator to specify the device that will be upgraded and the firmware image file that will be transferred to the device. Once the operator has identified the device and the supplied file name, negotiation is as follows. The host issues DFU detach on control EP0. The host issues USB reset to the device. I think that would be wrong in this case, because we're saying we detach. Well, that's a good question, isn't it? I'm trying to understand. Will detach there is described as the device will perform a bus detach attach sequence when it receives DFU detach request. The host must not issue a USB reset. So yeah, I think we're doing this right because thank you. Yeah, we are the ones that get to do the attach sequence. We probably want to say there's a 10 millisecond timeout on this happening, because we can reboot the device really fast if we want. But I'm just considering that the configuration data for this, we somehow need to tell the bootloader, hey, you're going in DFU mode now. And I'm just trying to work out, in my head at least, how that would work. What that will look like. Because this is a generic driver, so it doesn't actually know how to do that reboot. Oh, but we could... we could, as part of register handlers, have it take a function supplied by the firmware and put the onus on the firmware to know how to reboot into its own bootloader correctly. That's not a bad idea. We're going to have to make it so that the bootloader and the firmware agree on where the variable for this is. Okay, so in SPIFlashProgrammer, we need a bootloader directory. Oh wait, no, this was going to be dragonBoot, that's right. Let's do code, new date, new window, data programming, dragonMux, dragonBoot. So, first thing dragonBoot is going to need, mkdir deps, copy into here from from SPIFlashProgrammer. All of the dragon wraps. We then need a source directory, an include directory, and a build system. We'll need licensing code of conduct. What else am I missing? Clang tidy. This is stood C++ 17. We want those bits, because this is going to be its own ELF firmware output. Version's going to be very low. That's the subproject directory. We have to be cross-built, same as SPIFlashProgrammer. This song is just nuts. I love it. CXX, misong, get compiler, CPP. I don't need to worry about true and false for native because cross-compilation is forced. And then subdir src. And it's going to very quickly become obvious why I really wanted to have the descriptor stuff in Dragon USB, which we'll do in a moment, because that's actually going to cause us problems to not have. So we want descriptors cxx, and we'll need the startup code from SPIFlashProgrammer, but it'll be specific to the given target. There we go. So if we start poking some of this stuff I've just copied, oops. That was very much not what I wanted to do. That's better. Yeah, refactoring fun. So currently, we start the firmware at offset 0 into Flash, and it runs for some amount of the Flash. Now, if I recall correctly, the way that the TVC works with bootloaders is weird. So if we look in docs, microcontrollers, microcontroller that we're using, we're also going to need a chip variable, so we know what we're building the bootloader for. So for that, this is going to be meson options txt, and we take a leaf out of Dragon Tie, probably. Which, yes, is a nice little pun on Thai curry. Spicy. I'm bad, I know. So this needs to be non-yielding. And we'll have a ATX Mega 256A3U option in the future. Let's add that. Subdir get option chip, so that will pull in the right chip specific stuff. We also need licensing information. So this will be platform sources is a files object containing startup cxx for now. And again, this needs licensing. Out here, we have bootloader, sources, is platform SRCs, bootloader, CXX, and descriptors, CXX. The descriptors for this are going to be quite simple. We just need the one DFU descriptor, one config descriptor, one interface descriptor, and we are basically there. Though I need to get a vid PID for this. That's going to be fun. Go to descriptors. Run is going to be the bootloader entry point. That's how we've made things work within this platform system. The linker script is the one that I need to read the datasheet for. I actually think it was just SRC, not SRCs. Did I pluralize that? Question. No, I did not. Okay, so yes, that was right. What other options do I need to actually pass this? Oops. We will need Dragon Tie. But that'll be a platform specific thing. We will need Dragon USB. Which is not so much a platform specific thing. This needs one interface, no endpoints, one config descriptor, one interface descriptor, no string endpoint descriptors, and 3, 4 string descriptors, I want to say. And we want to compile in the DFU driver. Because this is a DFU bootloader. Platform dependencies wise, that's where we get Dragon Tie from. Actually, that would just be platform. Right, the Dragon Tie stuff, I need to tell it to not give me the linker script. Which I've forgotten how I do that now. I know it's not a thing you can do to dependencies though. Reference manual, return to objects, dependency object. We do dot partial dependency. Did I do this to Dragon USB? I think I probably did. Because this was the only way I could make this into a shared library without, oh sorry, a static library without screwing things up. Yep, there we go. Ah, what? That's annoying. Screwed up the copy initially, so it decided to be dumb. There we go. We don't need a default option there because of how this works. Did I make that so that it would inherit? No. Well, that's dumb. That will solve that. We then also need the cross-compilation stuff, which I'm going to copy in from DragonUSB. So, with the with DragonTie having its its link args turned off, we do have to specify here the linker arguments that we need. So we say, let's see, at one linker scripts.ld. I'm just gonna make chip a variable at this point, because we're using it everywhere. Like that. There we go. We will need those bits, and build by default. There's no point installation-wise. And I think because DragonUSB is using Substrate, we get Substrate for free. So I don't have to pull Substrate in this time, because it should automatically happen. Why is tab complete not working there? Cross files / none eabi cxc meson cross file cross files none eabi meson. So what I'm doing here I have a base level cross file which defines where my compilers are and how to find the LTO linker plugin that was missing information for dealing with AR. And then I have an overlay on that, which is the unknown EABI overlay, which tells the system all about how to compile for the actual target platform. Yeah, dependencies. Oh, missing a comma. I did. USB full substrate. Substrate configures properly. And then crashes because it decides it's having a bad time. Okay, there is not... Oh, because there's not yet a configuration present. Yeah, that makes sense. Platform SRC unknown because it's currently pluralized. That's fixed. There we go. So if we have a look inside this build directory at the configuration that we just got, we can see it's gone into a release mode by default. Optimization's level 3. We automatically got if release in ndebug there. It's automatically an LTO build. These are all things that the just noticing some of those are actually unnecessary now. These are all things that the cross files here dragged in. Likewise with the link arguments. Then chip here is set to our expected TM4C, etc. That is this project's configuration. Then Dragon Tie here, this is set to unknown because it's actually using this copy of the value. And then chip here is currently set as well because we're passing that through, though it should also be doing that wrap true thing. DFU is set by default, great. And everything else there looks good. And substrate is properly configured. So we've been able to build the USB stack just fine, though not the startup code. That's fine. So if we look in depths, Dragon USB, sources, lib, Dragon, that, is that the one? Yeah, so there's all of the .o files that we just caused the generation of. And there's the bootloader files that we built. Interestingly, I don't see the .a file, which is not actually a good thing. If I rerun Ninja, do we now get the .a? Yes, there we go. So we've now got our stack ready to go. Perhaps if I kill the console with that not maximized. So, let's see how bootloaders work on this device, if that's actually even in this manual. Which I don't recall if it is or not. Because this device itself, the DFU actually has an inbuilt bootloader as well. Just for added fun. But not one that we can use. Also, whenever anybody asks me why am I using a DFU, I quote them that the flash, the SRAM, and the EEPROM here are all single cycle. There is no caching required, none of that stuff. Yeah, I'm not seeing explicit, hey, here's how you do a bootloader. Yeah, it's either where bootloader is in the ROM. I don't want to have to deal with that because it's proprietary in a way that I can't use. I wonder if the NVIC can be told to move the vector table about. Because the processor will start up when firmware is present at address 0, which is the standard for a Cortex. But I have a funny feeling the NVIC might be able to be used to have the firmware's vector tables immediately follow the bootloaders and put the bootloader right at the very start of Flash. That could be quite good. System exception module, system control. Oh, nice. Unlimited access to the MSR, MRS, and no use of CPS instruction. Huh. I'm wondering why they ever... Ah, fair enough. I'm wondering why they ever actually added privileged, unprivileged modes to this thing, because... doesn't really make very much sense to ever get to use that. Yeah, those are the special registers. I don't have to care about those right now. I can use a register that's preserved through reset to tell the bootloader what to do. That's what we do for the reset, for the reboot, for the bootloader. And I just have to do some special stuff to be able to pass that into the bootloader main. The program status register. Yeah, I basically don't have to worry about those. Yeah, well, it's not wrong. Yup. Okay, so there's a way to be able to change which is the current stack pointer. Indeed. Third mode privilege level. Page 124 is the next big page, I think. This is all to do with like the bit banding, sync, exceptions. Vector table on page 106. Okay, 106 is apparently actually the next thing to do with the vector table. Oh, Ultra Sid is great, and unfortunately passed away last year. It's definitely worth listening to their stuff. They've absolutely amazing stuff. Yeah, this world's cruel like that. So, where is... Okay, we've still got a bit further to go until we find the... Oh, hang on, this is actually quite useful to know about. These are all of the ARM instructions that are present on this chip. And I need to see if there is a reset instruction, or how I might go about doing that. And reverse bits, reverse bytes. Yeah, there's no reboot or reset instruction, so we'll have to do that a different way. That probably means that there's some register you write to that does that. Probably in the NVIC. Oh, not in the NVIC, sorry, in the system control block. We aren't using the MPU. There's no point. Because it's so limited. Here we go. Register map for this is the sys clock, the NVIC. Here, there we go. System control block. This allows us to move stuff about. This is what I was looking for. So this is how this chip supports having a bootloader. So yes, we absolutely can do the thing I was hoping we could do, looking to do. So let's say that the bootloader is only allowed, that'd be 1024, 2048. I think it's that. Try that even, there we go. Okay. I've just told it a lot more than I wanted. What I'm looking to do is I'm looking to limit the bootloader to a maximum, actually at the moment, of 16 kibibyte. But if we can, we'll get it into 8 kibibyte. And then we can then say to the application, SPIFlashProgrammer here, that the where has it gone? We will say in memory layout here that the origin is at that offset address, and we will subtract that off the length here. So this is now the 3 3C. Okay. I can't do that in my head at the moment. So that will be... The firmware is now restricted to slightly higher up in memory, which is fine. And the bootloader... that's Dragon USB, whoopsie. The bootloader is then given the lowest chunk of memory. We can then have the bootloader, just prior to restarting into the firmware, change the vector table offset, and the firmware can then change it back when it wishes to reboot back into the bootloader. So if we look, box control, IT folding, right buffer, I probably want to say that we don't want enabling of multi-cycle instruction interrupts. We probably want to actually enable that bit. We'll come back to that. CPU ID base, interrupt control and state. So the offset must be aligned to a 1024 byte boundary. That is perfect. I'm going to say that that is therefore the bootloader's, that it's going to be a constant that we set, the uint32t application offset or base address. And we'll need the licensing information. Okay, so the first thing to do in the bootloader is going to be the descriptors. Let's get the descriptors written. Phantom Manic here is another good one if you want people to follow Weston. Oh, that wasn't the constants that goes to. That goes to this constants, which we're going to need a version of. So let's grab that. The descriptor. That all looks fine so far. EQ buffer size is what it is. Config count. Right, we need to grab that information from here. So if I grab a copy of that, we've got one interface, no endpoints, and 4 strings. That solves one configuration error, and the other one is this. And again, we need to adjust this. One interface, no endpoints. And 4 strings. Oops, 4 strings. There we go. Now the environment actually knows all about how that's configured. We need to do a git init. I've done a lot of work in this directory without putting it in version control, which is bad. So we want to add license, code of conduct, we then want to add welcome back. Me starting the bootloader itself, having written the bulk of the DFU driver and trying to get my head around how rebooting works on the T4C. We have found some very interesting things in the process. Oh boy, we have. So, git commit m added a clang tidy configuration for the project. We want to then nice. Ooh, excellent. I need to write a quick git ignore because currently I'm being a naughty girl, and we need to ignore dragon tie, dragon USB, and substrate. Ah, interesting. Oh, and we also need to ignore substrate.wrap That's a lot of adapters. Ooh. Added wrap files for projects dependencies. We then want to add cross files. Added Nissan cross files for the project. $500 adapters. Okay, yeah, that's just a few. That's very good. Gosh. That's cheap. That is surprising. That's surprisingly cheap. Cause you can put a decent markup on that. Hey Aki, welcome, welcome. I have been going insane in the membrane. You know, as you do. Insane in the membrane. Insane in the brain. It's okay. You needed the sleep. Oh yeah, for those who don't yet know, Aki and I have some fairly big news. In some time, about 2 months probably, I will be moving in with her. Which is a transcontinental move, of course. So, yay! It's about damn time. Thank you, Eston. I mean, you kind of already knew, to be fair, because, you know, but thank you. I appreciate it. Git ignore. We need to ignore /.ds code. Right. Nothing. Sure. So in the startup side of things here, platform HXX doesn't currently exist, which is, bad. I just had VS Code here lock up. One moment. Oh no. I'm just having a moment. This kernel null pointer error is terminal. I have to reboot now. It is. And it's an electron bug that keeps triggering a kernel bug that is somewhere in file system code, which is, you know, just where you want it, right? Oh no, you won't be seeing me in a bit. This is a 2.5-hour reboot. I will limp it along. We will see what we can get done in this time, but before I have to actually reboot. Because this is the big reboot. Yeah, this is not a small problem. I was gonna add a header. Let me do a thing first. Git commit. Because I can't. I bet if I try and reboot the process that I need to create stuff to be able to push. If I try restarting the GPU process, I don't think it'll work. I think it's already terminally dead. Yeah, uninterruptible, so I bet this won't work. Yep. Zombie. This is what happens when that bug happens. All GPU processors across my entire system, i.e. anything Electron or Chrome, is now dead. So, with that, let me see, git commit, added the initial, VS Code and everything else. Literally, Chrome, code, Discord, Steam. Yep, it's a Chromium thing. The chat overlay is done using a Chromium based system, Ceph, which uses GPU process, which has got this fatal bug in. It's great. Okay. This has been in the kernel since version 5.10. End of. So actually version 11 start. 5.11 start. So I'm not going to hold out my hope, because it's been 2 minors that it's been in the kernel for. Anyway, added the initial, code for the bootloader. I have no idea. Unfortunately. Alright, let's start a Tmux, because I'm going to need to be able to do some split screen stuff. So, on this side, and also I want one split down there. Yeah, I don't know what I'm looking for to check, that's the problem. Oops. There we go, that's what's wanting. Oh, it's not your fault. Right, includes... So we had, it was platform HXX. And the other bit I'm going to need here is in the Meson build system. An include directory that is that. And in platform, oh. That's what I was trying to do. That's right. SRC bootloader. Yeah, okay, that would be fine. Cute. So I think this needs to be extern void run. My build's not supposed to be hung as well. Really? Hang on. What did actually go wrong here? Because this might help identify why the build's now broken. But here, warning, K-fence. So in this function, it caused a K-fence unprotect to crash somehow. Which was caused for a sys at open at page fault oops. And then kernel null pointer dereference. In DLOOKUP. I'm betting there's a bug in DLOOKUP. That's what this smells of. Which is also part of the reason why this build is now not going to continue. I cannot kill Meson now. I now have a part of my disk which I can't access. Okay, let's try and get the descriptors written, even though they won't be able to be built yet because I can't compile anything. Yeah, ouch is the right word. Well, Meson is on my boot SSD, so something on my boot SSD is inaccessible now because of that kernel null pointer bug. That will be what that is. Oh, Zaza is another great artist. Aston, if you want more stuff to add to your listen lists. Firmware, USB, descriptors. Oops. Well, yeah, that's because nano is not a thing. Nanode, rather, is not a thing. A const std array of USB config descriptor t configs count just realizing when was it? Platform was what I added. That will make it so that the build passes and those two changes will make it so that it links correctly. Size of USB config descriptor t. This is a configuration descriptor which has the configuration descriptor itself, the interface descriptor and a DFU functional descriptor. Interface descriptor count's actually the wrong count to be passing back there. That's actually interface descriptors, or rather interfaces count. I think that's what I ended up calling that. It was constants. Here we go. Yeah, interface count is actually the correct one to be using. Here. Oh, I forget my menu key is currently broken on the keyboard because I didn't yet fix a little error I put in the code. It's sending back an illegal key code for menu, which is why it doesn't work. This configuration. No serial number string. So we've got a manufacturer, a product, no serial number string. We probably do want a string that describes this configuration. There'll be 3. We want defaults and at most 100 milliamps. We then have the interface descriptor. Oops. I have to remember, Tmux takes a moment for it to stop taking arrow presses as commands to change what console you're on. Not string. Array of USB interface descriptor P. So we've got interface index 0, which is what this is. I've just spotted an error over on this side. That looks good. And this is string 4. We then don't have any endpoint descriptors, for the obviously pre-stated reason we just don't have any. We do have a functional descriptor. Which I think it's fair to say that that's probably about the same for both parts. We said the detached timeout, we probably want to set that to like 10 milliseconds. Okay. We then have the table of configuration sections and then the resulting USB config descriptors, pipe. So having defined that, we can then define the individual section stuff. I've kept the naming the same, so I can just copy past some stuff here. It's not gonna copyright strike. I need to take that one out of rotation. We don't have any endpoint descriptors, but we do have our functional descriptor. We then have the string descriptors. Which has pretty much declared as is on the other side, so I'll just copy that so I don't have to type it all. This is the one that is kind of fixed in value. This is a bad alloc product after all, so let's do that. This is the Dragon USB DFU bootloader, which, how many characters is that? That is column 9 to column 33. 33 minus 9, 30 minus 6, 24 characters. Hey, it's the same as SPIFlashProgrammer Rev 2. The interface, the configuration is the bootloader DFU configuration. What actually? Yeah, that console's just dead. Trying to think how if I've got a good way to be able to just dump descriptors real quick. So if we do VD that, I'm trying to remember if this names any of its configurations. It does not. We'll call this bootloader DFU configuration. This is col 9 to col 37, which is 28. Nine, 10, 11, 12, 13. Yep, there's our 4 strings. Okay. Four and 5. And I think that's actually the end of the what I should have in this code base, because everything else from there down, the standard descriptor stuff, should really be in Dragon USB, which I now can't fix because, well, VS Code's broken. So, with descriptors written, implemented descriptors for the bootloader. I think that might be everything I can do right now. Let me fix some missing using namespace stuff. Oops, that's that, and then using namespace USB constants. I believe the USB core stuff is only used down at the bottom. Yep, there's USB core. Device as well, I don't think is used until I start having to poke around inside the packet, that is the setup packet stuff. So, fixed some missing using namespace. I hate that home and end are broken in Tmux here. That's entirely my fault, though. I need to tell Zish about how to handle that. Fix some missing using namespace. Declarations? Or usages. Usages in the descriptors. It looks like I need to do star.star.wp. Git commit. Added an ignore for Vim like swap files. That's what those are. Yeah, as expected, Chrome is screwed, so I can't. Ooh, no, I can make the repo. I'm just gonna have to use my laptop, which I'm using to view chat. One moment while I make a repo for this thing. This probably wants to use my security key. One moment. There we go. YubiKeys are very, very handy. Add new repository. This is under the Bad Alloc Heavy Industries moniker. The repository name is dragonBoot. It's not got a description for now. And there we go. That is now pushed. So you can all see the hilariousness I have just been having. We can see how badly broken this is on a system that can still build it. With that, I don't think I can do very much more without a reboot. It's very frustrating because I really wanted to try and get more done. Honestly, I wanted to be further into the bootloader process and actually be running the bootloader on the device, but this is incredibly limiting that I am unable to use my IDE, I'm unable to use the web, etc. properly on this machine right now, so I have to do a reboot. I might stream again partway through the week and try and get some more progress on this done, because I really want to get the DFU bootloader stuff working, due to it holding up the next bit of MX keyboard. The reason being, for those who saw the last MX keyboard stream, the reason we were seeing the processor just crash, it turns out, is this footnote in the documentation for the device, which basically states that if you want to reprogram application pages, that has to be done from the bootloader pages or from a connected programmer over PDI or JTAG PDI. If you want to reprogram the bootloader, that has to be done with the processor. Well, sorry, not with the processor, paused. Again, over that JTAG PDI or PDI link. It cannot be done from the processor itself, although you can leave the processor running if you like. And the user, what's his name pages, the JTAG. Nice. The other bit of memory that you can program in the chip has to be done with the processor stopped over JTAG PDI or PDI. That's the user signature page. There we go. Just gonna get it someday. Which is actually quite nice, because what that means we can do for the keyboard serial number is we can stick that data in the user signature page, or rather data for that in the user signature page. We'll probably make a composite serial number based off some other information I can pull from the chip to do with like where it was on the way for what lot number it had, etc., which will be quite nice to have as like a unique number. So that was the limiting factor for the keyboard, and the way I want to fix this is I want to get the DFU bootloader written and working on the ATX Mega, hence DragonBoot, and put into the bootloader at a fixed point in the bootloader. There will be a jump table defining things that the firmware can jump to that are helper routines in the bootloader. Or, for example, rebooting into the bootloader can be accomplished this way. And the other part of this is the routine required to do the atomic erase writes gets put in the bootloader as well, so that the firmware can call it to rewrite its own pages without booting into the bootloader first. Hopefully that makes some sense. But yeah, that's the reason why the bootloader was sorry, the MX keyboard needs a bootloader. Yeah. Anyway, with that, I will see you all on my usual time next Saturday, regardless of what happens in the middle of the week. For probably another stream on this, if I haven't managed to get it finished by then. Thanks for all for watching, and I will see you next time. Bye for now.